Hello everybody, let us solve the third problem. Okay. Find the contents of the accumulator after execution of the following 8085 assembly language program. So move immediate A 42H, move immediate B 05H, then we have a label, we have add B, so decrement B, then jump if not 0, JN is Z of lab is the label. So then add immediate 25H and halt. So we will try to solve this problem. So first we have in A we have 42H, in B we have 05H. Now we have to add B to A. So we have to add B, no? So we have to add. So we have to add 47H. So this is the value after adding B. Now we have to decrement B. So this is the accumulator value. Now we have to decrement value of B. So previously it was 05. Now when we decrement it becomes 04. Next then we have to jump again to this label, then again we have to add only. So what will happen will be 47H plus 04. So it will be 7 plus 4, that is 11. So the value of 11 will be B. Okay, so 4B. So the value will be 4BH. Okay, next again it will decrement B, so it will become 03. Now add the value, add B means it will again add, so 4B and 03 will be added. So what is the value of B? B value is 11. Okay, 11 plus 3 is 14. So what is the value of 14 in hexadecimal? Value of 14 is E. So E 4E. So here the addition we have 4E. Then again the value of B will be decremented by 1, so 02. So then what happens? 4E and 02 we have to add. So what is the value of E is 14. Then we add plus 2 means 14 plus 2 is 16. But 16 we can't write in this. And so what we'll do, we will subtract 16 minus the base, that is 16, which is 0. And since it is a carry, we can't write value, so it is a carry, so we write 0. The subtracted value right here, and we add a carry, that is we get 50. So this is the value, current value in the accumulator. Next again it is decremented. What is the value of decrement? After decrementing B, we get 01 as the value of B. Next we have 50 and we have to add 01. So it will be 51. So 51 will be there. Next when you decrement, the value of B becomes 0. Now when it becomes 0, what will happen? It will exit from this loop. It won't be added and won't be decremented, so it will exit from the loop, and then it will come again next line. So next line what they written, ADI, that means add immediate 25H. So currently the value in the accumulator is 51H. Okay, then we have to add 25H. So 25 you are going to add. So if we add these two values, what the value you get? 5 plus 1 is 6 and 5 plus 2 is 7. So the value is 76H. So the contents of the accumulator will be contents of the accumulator after all these operations. Okay, after all these operations, the contents of the accumulator will be, value will be 76H. So this is the value answer. Now the fourth problem, for a 1M into 16 memory chip, how many address lines and data lines are required? So they given a memory chip that is written as 1M into 16. So we have to find out the number of address lines and data lines. So what is the general format for the address and data lines? It is 2M into N. So this is general format for address and data lines. So here N is the number of data lines. N is the number of data lines and M is the number of address lines. So they have given a 1M into 16 memory chip. So here we have 16 is the number of data lines. So it is N, so N is 16. What is the value of N? N is 2 per m. So what is given? It is given in 1 m. M means what? Megabytes. So it is 2 per 20, right? So 2 per 10 is kilobyte, 2 per 20 is megabyte. So m, it is 2 per 20. So 2 per 20 and to n data lines, that is 16. Hence the number of therefore from this we get the number of data lines as 2 per 20. The number of data lines will be equal to 20. Just you have to know this format. Okay, if you know this format, you can easily solve this problem. Okay, so 16 will be the mean as such. It is the number of data lines. Number of address lines alone you have to find out. Write it as in power of 2. So depends on what are the value given. It's given in 1 m, so we write it in as 2 per 20 bytes. So 2 per 20 MB. So write it in form 2 per 20, and then we find the number of data lines will be number of address lines. So it's not data lines, it is number of address lines. Therefore the number of address lines is will be 20. So data lines is number of data lines is 16. The number of address lines is 20. Okay, so this is the answer. Next we have a comprehension type of question. Consider pipeline having 4 phases with the duration 60, 50, 90 and 80 nanoseconds, and the last delay is given as 10 nanoseconds. Now we have to find out the value of pipeline cycle time, non-pipeline execution time, speed up ratio, pipeline time for 1000 tasks, and sequential time. So we'll solve this problem. So first, so here they given there are 4 phases, that is 50, 60, 90 and 80 nanoseconds. That is the task is done in 4 phases. Here, if you need the pipeline cycle time. So what is the pipeline cycle time? So pipeline cycle time will be the maximum of the phases. Okay, so inside cycle, that is the pipeline cycle time will be the maximum of the phases. So there are maximum of 50, 60, 90 and 80. Okay, so what is the maximum? Maximum will be 90. Okay, and then we have to add the latch delay also. So latch delay is given as 10 nanoseconds. So 90 plus 10, which is equal to 100 nanoseconds, which is the pipeline cycle time. So this is the answer to the first one, that is pipeline cycle time. Next, non-pipeline time. So what is the non-pipeline execution time? So without pipeline, when we execute means we have to go through all the phases. So what is the phase? There are 4 phases, right? So that is 50 plus 60 plus 90 plus 80. So in one pipeline we have to pass through all the 4 phases. Okay, so 60 plus 50 plus 90 plus 80. So this value will be 280. So this is 280 nanoseconds. So this value will be the non-pipeline cycle time. Next, this is the speed up ratio. What is the speed up ratio? Speed up ratio, that is the this ratio between the non-pipeline cycle time, by the pipeline cycle time. So what is non-pipeline cycle time? That is we found out it is 280 nanoseconds. What is pipeline cycle time? That is 100 nanoseconds. So this will be 2.8. So the speed up ratio is 2.8. Next, so the pipeline time for 1000 tasks. So what is the pipeline time for 1000 tasks? So number of tasks is 1000. So we know one pipeline we have cycle time is 100 nanoseconds. But first for our pipeline, the first task will be covering all the 4 phases. So first pipeline cover all the 4 phases. Then from the next task only the pipeline will be happening, and this will come under in the pipeline. So the first task will be the first task into on the 4 phases. So this value will be 4 phases, right? So 1 into 4 into 1 cycle time. So 1 into 4 into 1 cycle time plus remaining how many tasks are there. One task is there which covers the 4 phases, and then with the 1 cycle time, and then remaining the 9 tasks will be completed in 1 cycle time. Okay, so this 1 into 4 into what is 1 cycle time, that is 100 nanoseconds. Okay, plus 999 into 1 cycle time is 100. So that is 400 plus 99900. So this value will be 9900 and 400. So it will be 100300. So this is the pipeline time, nanoseconds. This is pipeline time for 1000 tasks. This is pipeline time for 1000 tasks. Next they are asking the sequential time, that is non-pipeline time only. Sequential time means non-pipeline time. So sequential time for 1000 tasks. So what is the sequential time? What is the sequential time for these 1000 tasks? So say in sequential non-pipeline time means that is it takes the 4 phases, and so it is one cycle will be happening in 280 nanoseconds. So there are 1000 tasks, so it will be 280 into 1000, which is equal to 280000. So this much nanoseconds for non-pipeline, and this is for pipeline. So this is the computer system architecture is over. So we have completed all the units, and we have taken up some 4 or 5 problems, very simple problems only, but these will be very useful to those who are doing or preparing for NET or SET exams. Do watch my previous videos, and it will be useful for you, and write whatever your feedback in the comment section. If you need any notes for paper 1 or paper 2, also you can write it to this email ID. It is meerag10@gmail.com. Okay, so that I can help you. Thank you.